Okay, so this is the video going through the Unit 12 review on circles. And there's kind of a lot of information in this unit, so I wanted to have a review video to kind of help you consolidate all of that and make sure you can connect it all. So the first one, we have just one piece of information. This angle right here, it tells us is 20 degrees. And using that information, it wants us to answer 1 and 2. So the first question is, what is the measure of angle QTS? So if I look here, I have QTS is this angle right here. So if this is 20 degrees and it comes from points Q and S, and this one comes from points Q and S, well then these two angles have to be the same. So if this is 20 degrees, this is also 20 degrees. And then the second question asks for the arc QS, and it's asking for the degree measure, not the length, and that's what this little symbol here is for. So if I look here, this angle is 20 degrees, and it's from the same points as this arc. And inscribed angles are half of the arc angle, so if this is 20, then the arc has to be double that, which is 40 degrees. Number 3, now this time we're asking for arc length instead of the degrees of an arc. So to find the arc length, we have the fraction of, whatever fraction of the circle this is taking up. So it's 75 out of the total 360, and then we multiply that by the circumference, which is 2 pi times 9. So if we go ahead and enter that in a calculator, I have 75 divided by 360 times 2 times pi times 9, and that comes out to be 11.8 inches, which is B. So 4, 5, 6, and 7 are asking us to convert between radians and degrees and radians. So we need those two formulas to help us to do that. So if we have it in degrees, we want it to be in radians. We're going to go ahead and do degrees and then multiply that by pi over 180. And then if we already have it in radians, we want it in degrees. We'll take those radians and multiply that by 180 over pi. This says to leave as a simplified fraction. I'm not super worried about that. I'm fine with it as a decimal, but I want you to just either way, fraction or a decimal, I'm totally fine with either way. So I'll show you both ways. So if we have a 90 degrees and we want it in radians, I'm going to use the radians formula, which is 90 degrees times pi over 180. So if I wanted to leave it as a fraction, I would just kind of do it a step at a time. So 90 times pi, I have 90 pi over 180. And 90 over 180 simplifies to 1/2. So this just simplifies to pi over 2. But if you wanted it in a decimal form, then you could just enter it right in your calculator from the very beginning, and you end up with about 1.57 or 1.6. So either of these answers are acceptable. If you're answering a multiple choice question and you get 1.6, well, you could go through each of the answers and just divide pi divided by 2 in your calculator and see that it's 1.6. So you can kind of figure it out from either way. And then the same thing, if you get pi over 2 and you have decimals as your options, you can just do pi divided by 2, see what the decimal is, and look for that in your options. So it's pretty easy to go back and forth between the two. Number 5 is just the same as number 4. So I have 240 times pi over 180, which simplifies to, let's see, 4 pi over 3, or in decimal form, I have 4.2. So again, either of these answers are fine. Number 6 and 7, we're going reverse order, so we already have the radians. We want it to be in degrees. So I have pi over 4 times 180 over pi. I'm now using my degrees formula. So if I go ahead and simplify that, put that in my calculator, so I can put this in and then this in, and I'm left with 45 degrees. And then the same thing on number 7, I have 5 pi over 3 times 180 over pi. So then I have, if I enter that in my calculator, I am given 300 degrees. Number 8 I'm given the circumference and it asks me for the area. So the biggest thing with this is you have to find the radius first. So even though it doesn't ask you for the radius, you need the radius to find the area. So I know that my circumference formula is 2 pi r and my area formula is pi r squared. So if I have 2 pi r as my circumference and that's equal to 6 pi, then I can divide both sides by 2 pi, and you can totally just stick this in a calculator, and your radius is 3. So once you have your radius, then to find your area, you can just plug 3 in for your radius. So you do pi times 3 squared. Well, 3 squared is 9, which is 9 pi. And in this case, it actually doesn't even simplify from there. It just has 9 pi inches, square inches right from there. Okay, on numbers 9 through 14, we're using this circle right here. And the first thing before I even look at the questions is kind of remind myself what I know about this. So I know that the central angle and the circumscribed angle add to 180. These two right here add to 180, which means these two also add to 180, and they're the same. So these two angles are always 90 degrees, no matter what circle you're dealing with. Your radius and your tangent line are always hit at a 90-degree angle. And then I can find this angle because these two add to 180, and 180 minus 70 is 110 degrees. So if I look at my questions, the first is, what is the degree measure of SRP? SRP, that's this angle right here, which is always, always, always going to be 90 degrees. And then number 10 is asking for RST, which I just found is 110 degrees. Okay, and then I'm going to go ahead and copy the circle down to the next page so that we can look at it as we're solving 11 through 14 without having to scroll back and forth. So we'll go ahead and put it right over here. So now it's asking for the circumference of circle P. Well, all we need for circumference is the radius, which is 5. So I'm going to do 2 times pi times the radius of 5, which simplifies to 10 pi, or if I do 10 times pi in my calculator, 10 times 3.14 is 31.4, and this is inches, so this is inches. Then the area of circle P is from pi r squared, so that's pi times 5 squared, which is 25 pi, or again, when I simplify that, 25 times 3.14, this is 78.5, and now that I'm dealing with area, this is square inches. And then it's asking for arc length. So arc length, we actually did one up earlier. Arc length, we find our section of the circle, so it's asking for TR, so it's 70 degrees out of 360. And then we multiply that by the circumference, which is 2 pi and a radius of 5. So if I enter that in my calculator, I'm left with about 6.1 inches. And then 14 is asking for the area, so I'm still taking whatever fraction of the circle I have, which is 70 over 360, but now I'm multiplying that by the area, which is 2 times pi, which is pi r squared. So I'm going to multiply it by pi, and then by the radius squared. So when I enter this into my calculator, times pi times 25, I have about 15.3, and then this is area this time, so this is square inches. All right, 15 and 16, I'm using this figure right over here. So I'm given my central angle. So this is just, I need to remember some relationships. So your central angle and your arc are always the same. So if this angle is 75, this angle is 75. And then your inscribed angle is half of that. So half of 75 is this angle, which is 37.5 degrees. So over here it asks for WZY, That's this one, so that's 37.5 degrees. And then arc WY is 75 degrees. And then 17 and 18. So when we have a circle and a quadrilateral inscribed in a circle, the number one thing we need to remember is that opposite angles add to 180 degrees. So these two angles add to 180, and these two angles add to 180. So using that information, I can solve for x and solve for y, because x plus 20 is equal to 180. So if I solve this for x, I get 2x plus 20 equals 180, or 2x equals 160. If I divide by 2 on both sides, x is equal to 80 degrees. Then I use that same idea for y. So y plus 10 equals 180. So 2y plus 10 equals 180. 2y equals 170. And then y equals 85 degrees. All right, for this next section of the review, we're talking about equations of circles. So the first thing we're going to remind ourselves of is that in an equation of a circle, these 2 points give me the center, and the square root of whatever it's equal to gives me the radius. So my center, and the signs are opposite of what you think. So my center is at 2, -7. So I get my 2 from here, my -7 from here, and my radius is the square root of 9, which is 3. And then 20 seems a little bit weird because it doesn't have numbers there. That's because my center is at 0, 0. So it would be like saying x plus 0 squared plus y plus 0 squared. Well, that's a little unnecessary. We can just know that our center is at 0, 0. And then my radius is at the square root of whatever this is. Well, that doesn't simplify nice and pretty like the square root of 9 does. So we can just write the radius as the square root of 13. And then 21, I'm going in reverse order and I'm writing my equation. So my first part is 0. Well, for that, just like we just talked about, I don't need to do x plus 0 squared. I can just do my x squared. And then it would be y minus a -3, or y plus 3 squared, equals the radius squared. So 8 squared is 8 times 8, which is 64. And then the last problem from our review, it has us identifying the center and radius, but it's not in the form that the rest of them were in, so we need to get it into that form. So to start, I need to put my constant on the other side of the equal sign, so I'm going to add 3 to both sides. And then I want to put my x's together and my y's together. So I have x squared plus 4x plus y squared minus 6y is equal to 3. From there, I need to go ahead and fill in these blanks. To do that, I take my b term, or my middle term, divide it by 2. So 4 divided by 2 is 2, and then square it. 2 squared is 2 times 2, which is 4. But if I'm going to add 4 to this side, I also have to add 4 to this side. Then I'm going to do that same process over here. So -6 divided by 2 is -3. -3 squared is -3 times -3, which is 9. So I'm going to add 9 to both sides. So now with these two, these are now quadratics that I can factor. So I need two numbers that multiply to 4 and add to 4, which is 2 and 2. So this factors to x plus 2 times x plus 2, or x plus 2 squared. And the same idea over here, I need two numbers that multiply to 9 but add to a -6. Well, 3 and 3 multiply to 9 and a +6, so a -3 and a -3 would add to a -6. So this is y minus 3 squared. And then that's equal to 3 plus 4, which is 7, plus 9 is 16. So now this is in the same form as the ones above, and I can find my center is at -2, 3. And my radius is at the square root of 16, which is 4.